here, and welcome to part 3 in a series of videos that accompany a Medium article that I published some time back on the topic of customer lifetime value. And that's a concept that comes from marketing analytics, and it is a means of valuing your customer relationships and making predictions about customer purchasing behaviors. And it does it with something called buy-to-die modeling and a Python library called PyMC Marketing that uses Bayesian statistics. And as I mentioned, this is a third in a series of videos that follows an earlier video on buy-to-die modeling and a second video on Bayesian inference, Monte Carlo simulations, Markov chains, and hierarchical models. So this article has a Python notebook that you can follow along, and in today's video it's going to be a code walkthrough. So rather than work on PowerPoint, what we're going to do instead is we're going to start looking at some code, and this code is available in a GitHub repository, but it's also in a Kaggle notebook that you can follow along, and we'll be doing exactly just that. And as with all forms of analysis, the very first step is data loading and a bit of cleaning. So let's have a look at the notebook. So we're going to pull data from a online retail data set that covers the period of 2009 to 2011, and it's freely available from the UC Irvine machine learning repository, and some useful information about the data set, where it says here that you may want to have a look at invoices that start with the letter C. So the first step is let's do a bit of cleaning. So we're loading the data, pull in some libraries, have a look at the columns and how many rows there are, and let's take a closer look at the cancelled transactions, and you can see that they're all negative valued transactions. There are quite a number of them actually, 20,000, well, a bit less than 20,000 rows, but for simplicity we're just going to wipe them out for the purpose of this walkthrough. And the next thing we'll do is we will also drop the blanks. So we're going to do a drop NA, and we're going to do a bit of formatting in terms of the date column to make it kind of cleaner, and I think we are more or less ready now. The next step is around time aggregation, and what I mean by this is we've got data that has different levels of granularity, and if you look at the data set itself, you notice that it's got the dates, but it's also got like down to the transaction times. And when you're doing this kind of analysis, you need to figure out what's the granularity that makes the most sense. And what I've done is I've written a bit of a simple function that takes transactional data, and you can specify the granularity that you want to see it, and you can go all the way from, let's roll everything up, by customer, by transaction, by year for this one. And you can see that in this case, this customer number 12346 made 5 purchases in the 2009 calendar year, with a total of £113, but year doesn't really make sense, so let's drill down a bit further. We'll try months and weeks, but days seems to make the most amount of sense. So this is a case where you can see that, example, this customer, they actually made 2 different purchases in the same day, but the grand total of both those purchases is £731. And you may be wondering why I'm spending so much time talking about granularity. this becomes quite important later because we're going to be doing something called buy to you die modeling, and the granularity of whether it is at a day level, week level, month level has an impact on how you work the model. So we're going to go with day, partly because it makes the most sense, even though we will see later that in some cases you get a customer buying multiple times in the same day, but for the purpose of the analysis, we're just going to treat it as they bought on that day or they didn't buy on that day. Now, always good to do a bit of data exploration before you dive in to do any form of analysis. And what we've got is I've made a plot of how much the spend is over time, and you can see in this chart looks like there's a bit of a seasonality going on here, where the amount of sales goes up towards the tail end of the year, which is not surprising. So you get kind of Christmas season, and then it dips back down, and then Christmas season again. Most of the transactions are from the UK, which makes sense because the dataset itself says that it is for a UK-based company. World War II gliders seems to be the most popular product. I'm not sure whether that's significant. Interesting though. And we've also got a plot of which customers have bought the most by dollar value. And I've also plotted a histogram of that. And this is an interesting picture because you can see that out of all the customers, the bulk of them actually don't spend very much. There are a few, like these ones that you see here, that spend quite a fair amount, 600,000. But you know, that's far and few. Most of them actually spend a much smaller value. And the other chart that I've put together is the earliest order date by customer. So it's a proxy for, you know, when did the customer start buying with this company, and you can see that there's a bit of a spike, but in general it looks like a bit of a downward trend over time in terms of you're not getting as many new customers, so you're really kind of generating your purchases from existing customers. What we're going to do next is we're going to split the data, and we do this using a scikit-learn, and we're just going to keep it simple. So 30% of the data set in total is going to be a test part, and the 70% will become the training part. So we're going to make that split, and we're going to grab some information about how long the training data is. Looks like it's about a bit about 2 years worth roughly, and I think we are more or less ready to get started. Now we're going to talk about RFM. In fact, I actually have a whole article that I have posted up on Medium some time back, Medium sometime back, where I covered the topic of RFM segmentation and using a algorithm to do clustering. But for the purpose of buy to you die modeling, we do need a bit of a sharper definition. And why I say that is because if you look online and you just search for RFM definition, you get definitions like this, you know, how often you buy, how much money you spend, how recently a client purchased a product, or you know, the time since the last engagement with the product, freshness. The challenge is for this kind of buy till you die analysis, there is a very specific way that you are actually trying to measure recency, frequency, and monetary value, and they don't always line up, and it's not always intuitive. So what I did in the notebook which is probably overkill, is I created a bunch of functions that allow you to consume transaction data and pull up a whole bunch of different fields, and you can follow along on your own. I just wanted to sort of get to the tail end where just to kind of contrast what's the difference between your intuitive understanding of frequency versus how you would need to do it for buy-to-you-die modeling. And I think the first one is that the frequency is actually frequency minus 1. And there's a very specific reason for that, because the frequency is actually less 1, because you need the buy-to-you-die has this whole bit around you need to look for repeat customers, so you don't count the first purchase, so it's frequency less 1. The second bit that you need to be aware of is the recency itself. You would think that it is the reference date minus the last date, that the most recent order date. However, the actual definition that the buy-to-you-die models actually use is the first purchase date till their most recent purchase, which is a little bit different. And the last bit is the monetary value, which you would say, well, it's everything that the customer has purchased. But again, going back to this whole idea of repeat purchases, you actually need to remove the very first purchase that you made, and the whole bit about, you know, why does that time granularity matter is because if you're choosing it by day and you buy multiple times in the same day, you treat it as one purchase, so the whole day is a purchase. So you have to subtract the total monetary value against that first time, and then divide it by the frequency less 1. This is not at all obvious, and it took me a while to kind of figure this out, reading the background on how these RFM dimensions are calculated. But this is why I actually wrote a function, just to kind of give myself the surety that it makes sense. The good news though is that PyMC Marketing, which is going to be the library that we use, actually has a one-liner that does everything for you. But it doesn't tell you all the details that I just showed, but you can see that this customer 14911 is a frequency of 172, 555, and 1132, and the work that I did above was actually just to satisfy myself that I understood why it was coming out the way it was. So you get 172 because it's frequency less 1. The monetary value is in fact not the total divided by 173. It's actually this value less 733 divided by the frequency minus 1. And recency is these two dates, the first date that they ever bought versus the most recent date that they bought. So it's good to kind of just validate, and I've done that step. So the PyMC Marketing in a way allows you to skip all that work. But before we start looking at the automated feature in PyMC Marketing that calculates RFM, worth looking at the shape of the RFM information by itself. And you can see there's a lot of skew. These things are not demonstrating a normal curve, which is why if you try to do a simple average of customer lifetime value, because you do see this in quite a lot of online websites, they say take the annual purchases per year times how long you think a customer is going to be around. You can work out what is your customer lifetime value. And we try to do that using the RFM information, because you can get the average monetary value, the average frequency, and it all comes up to about 1.8 K pounds in terms of average customer lifetime value, although the reality is talking about averages may not mean very much, given the fact that the customer base itself has a quite a skew and is very homogeneous in nature. So that kind of covers the all the stuff leading up to the actual analysis in PyMC Marketing. And PyMC Marketing is a library that allows you to use Bayesian statistics to estimate certain marketing type analytics, and buy to you die modeling is an example, and estimating customer lifetime value. And they've got a quick start for customer lifetime value and a few other portions on buy to you die modeling that I've adapted against this data set. So very first step is you get your transactional data and you call up the utility function to produce the RFM summary. And here it is. You get 4,900 plus customers that are unique, and they have this behavior in terms of their recency, frequency, and monetary value. And the first thing we're going to do is we are going to fit the data to the BG-NBD. So that's beta geometric non-binomial negative binomial distribution. And so if you have no clue what I'm talking about, you might want to jump back and have a look at the buy to you die modeling video, where I go into a lot more detail about how it works. But from a programming perspective, relatively straightforward. Now, the documentation itself on the PyMC Marketing has an example where they use something called the MAP as a first step. So this is kind of a quick way of getting a number, and using something called maximum a posteriori. It's not really the recommended way to do the analysis, but it is computationally a bit quicker, and by feeding it the data that in the RFM form, it produces a set of variables that define the model that governs frequency of purchases, and also the dropout rate, how long the customer is going to stay alive. Now, the MAP method is something that produces point estimates, but the whole power of PyMC Marketing is that it allows you to do Bayesian inference, and that's what we're going to be doing instead, where we will use the MCMC method, and this is a short for Markov chain Monte Carlo. Again, if you have no idea what I'm talking about, I've got another video that talks about the Markov chain Monte Carlo sampling. The short version is this is a statistical method that tries to fit the data against the distribution, statistical distributions that we think will describe the customer purchasing behavior and dropout rates. And we run the model, and you can see it does it over 4 different chains with 2,000 iterations each time. Again, if you've no clue what I'm talking about, you need to go and watch the second video where I cover the details of how PyMC Marketing works under the hood. Long story short, it produces a fit with a certain what do you call it? A certain error kind of confidence interval. It's not exactly a confidence interval, but it's about the same. And you can see that the these are the 4 variables that define the BG-NBD portion of the buy till you die model, and that has been fitted against the data. And what I meant when I said that it was using a probabilistic statistical inference method to get the number is you can see that they had the 4 different chains of simulations, and when you overlay them, what you're trying to do is get the overall aggregated results in order to derive what is the A, the alpha, the B, and the R that define the beta geometric negative binomial distribution. This allows you to do a couple of interesting things. One example is you can plot the frequency against the recency for the all the customers that you have, and you can see that you've got the most recent customers, the ones that I think at the customers with the highest recency are about 500-ish, and you can see that this is the frequency, and the color I think represents what in the world does the color represent? This represents the expected number of future purchases per unit of time. So the second thing that you can also plot is whether the customer is going to be active in the future on whether based on all the information, whether the customer is still active or not against a certain chance. And this chart is kind of interesting because it has a bit of a one corner the customers who probably tried it once and left, so you can see because their frequency was very low, and they haven't bought something for quite some time, so they probably tried it and left. You've got customers that are new because they've got high recency but low frequency. You've got customers that are kind of loyal repeat customers because they've bought a lot and they've bought recently, but the ones you need to be worried about are the ones that have bought a lot but haven't bought recently. So this is how you interpret this plot for chance of being alive or dead, where the dark color is bad, you want them being light colored. Jumping back to the code, we can also look at the individual customer where we've just picked out a random customer, and I'm sure there's a better way of doing it, but I kind of had to just pull in some data by hand, and this is just showing a hypothetical situation where it's not hypothetical, this is actual data. For this particular customer, you've got the at a certain point in time step 70, they've bought twice, and the most recent time they bought was 70, and we're increasing the time step, and we are trying to kind of plot the chance that the customer will purchase again. So what you see is the chance declines after each purchase. For the longer time that they don't make a new purchase, so when time progresses, the chance of them still being active diminishes, but when they make a new purchase, in this time step 75, was it? 74, I'm sorry, it jumps up again, and then it begins to decline again, and then when they make another purchase, it jumps up again. So this is a plot showing the probability that the customer will purchase again, and the blue line is the range of that probability. Now this is all fine and good, but what we want to do is actually also pull it all together with the monetary portion, and this part is modeled very closely against the quick start in the PyMC Marketing documentation for the gamma model. that model's monetary value. And what we're going to do is, one of the gotchas is that you can't use your whole data set. Again, they don't really make this very clear in documentation, but you need to like filter out the ones that have more than one purchase, because this is something that the other part of the model that looks at frequency of purchase and dropout rates can take the whole data set, but for the monetary value, you have to actually only take the ones that have bought more than once. And the other thing is you need to watch out to see whether or not the monetary value and the frequency are correlated. This one is not very intuitive, but it has to do with how buy to you die modeling works. They are assumed to be not correlated. So here we've got like a 0.13, which is okay. So we think that the buy to you die model is valid, and we start to build the model under this gamma distribution, and we do the same thing where we start first with we fit it just like we did using 4 chains, 2000 iterations each chain, and again it's a probabilistic fit using Bayesian inference with Markov chain Monte Carlo sampling, and you get the variables for P, Q, and V, and it gives you how the whole thing looks like in terms of the model. Now that you've kind of trained the model for both the frequency and probability of still being active as a customer and the monetary portion, you need to pull it all together. And this is a code that kind of looks at the model prediction against the test data, and let's see how it performs. So we're going to use RMSE, so that's root mean square error, and the mean absolute error, and you can see it's not fantastic. It's okay. So you get like kind of a error of 4 and error of 6, which feels kind of high, but you know, it can also be the fact that you've got quite a lot of skew in the data. MAE provides the slightly better results, but yeah, I think the reality is you've got quite a long tail distribution for how your customers behave. So maybe RMSE and MAE is not the best measure of how well your model is performing. When you look at the sample code from PyMC Marketing itself, doesn't really have too much to say about, you know, what you can use to kind of validate the data. So happy if you put a comment in the video on how you've done it in practice. Moving along though, what we really want to do is estimate customer lifetime value beyond the holdout period, because that's an interesting piece where, you know, you've got the train data and the test data. You want to go beyond the test data. So what we're doing here is we're taking the entire data set, train and test, and we are using the train model, and we're going to make predictions around for the entire data time set between the training and the testing. What is the predicted probability that the customer is still active? And this gives you something that you can work on. So maybe you want to intervene, and you can say for all customers that have a less than 50% chance of being active, we're going to intervene and we're going to send out a special offer to this customer to say, hey, we notice you haven't bought in a while, here's a voucher or a discount, This thing also makes predictions around how many purchases they will be having in a specified period. And here I've done it in a year from as is. They will make an average of an expected 1.7 purchases, and this is how much we think they spend per transaction. And this is the next piece that talks about combining the model with the piece that the part of the model that looks at monetary value, and to estimate customer lifetime value. And here you get not just a simplistic average customer lifetime value, but a discounted customer lifetime value, where you assume a certain discount rate per month, and it calculates the discounted CLV for you, and you can see which customer has the highest overall customer lifetime value. And again, that's useful for focusing your customer relationship building with the high value customers. Now, what I've done here is I've also pulled in the discounted CLV mean, and you can see it's about 1.5. You can argue, hey, 1.5 is not that different from 1.8. Was it worth all the effort? It kind of is, because the whole point wasn't just to get the mean, it was to kind of understand the behavior. And by doing this kind of buy till you die analysis, you actually understand more about not just the average, but every single individual customer. You've got the ability to make predictions about, are they going to be likely to still continue buying, how much are they going to buy, how much is it that they're going to spend per transaction, and their overall customer lifetime value, which is really useful, because at the end of the day, this kind of analysis is about helping marketers improve the customer retention and building that relationship. So this has been one of the more dense videos that we've had out of the series, and necessarily so, because I think this really goes into the code. So I hope this has been something that you guys have found useful. Leave me comments either in the YouTube video, the Kaggle page, or the Medium article. I'd love to hear back from you, and I guess I'll see you in the next video. Bye bye.